Okay, time started now. Great, so thank you very much guys for coming to this session that it's called Lesson Learned from Java EE to Spring Cloud and Beyond. And I think that that and beyond part is quite important. Also because the title is a little bit long, I didn't include in the context of an open source project, which I believe it's also important for this presentation. I will be describing some of these topics and my journey from coming from like the Java EE world to Spring Cloud and some other things. But from that context, coming from the context that I'm working for an open source project, and sometimes what the things that we do in open source projects are a little bit different on what's happening in private development. So take that into account. So the agenda quickly, I will start basically going through what this presentation is not about, and I will give a quick background of what I'm doing, what's my, my background on technology and software development, what I'm doing currently, and the kind of projects that we are building. And then we will just jump into the painful journey to cloud-native applications. And this is definitely related to, Spring Cloud and how these technologies are going through that. And talking a little bit about what's happening in the Java EE world, like Jakarta EE nowadays, not more Java EE, and the microprofile and that kind of things. I will just quickly go through that because that's where I'm coming from. And in order to explain my journey to, the other side, I would definitely want to touch on those topics. And then talking a little bit more about cloud-native applications and, containers, Kubernetes, and what's coming further down the line. So this presentation is definitely not about Jakarta EE nowadays versus Spring Cloud. It's not about what's best. It's not about, which one you should choose. These are tools. These are frameworks. They are based on different principles in general. They are kind of converging when you go to these two website sites. They talk about similar things nowadays, and they all try to be as slim as possible. So I will not be talking about size. I will be talking more about the decisions that you need to make in order to create real-life implementations with these technologies. And the journey, again, in the context of an open source project that we are taking in order to adopt these technologies. A little bit about my background. I started coding about 14 years ago, Java applications. I created a lot of small applications, large applications, and then I went into a different area, which is system-to-system integration, system integrations in general, because I was really amazed about how multiple applications can interact, how they work. At that time, SOA was kind of like big, so I started researching, and I went into this open source application server that it's called JBoss. Nowadays it's Wildfly. And I started getting involved in those communities. I started doing some contributions in their stacks, in their libraries. As you might know, like an application service is just a bunch of libraries all put together, working together based on something. In that case, it was the Java EE specification. So I got involved with some of these projects to later find a more specific section in there, which is process engines and rule engines. So I started collaborating and participating in these communities, JVPM and rules. So my background went a little bit on how do you solve business problems for people, right? So you are using technology to provide some solutions for people to build on top and to interact with their domain experts, right? If you join the previous talk about DDD and microservices and what kind of patterns do you need to use in order to do that, well, these technologies are kind of like related to that. You need to make sure that you reduce the gap between your business experts and your technology department in order to be able to provide solutions for that business. So I went there, I started collaborating with these projects until I got hired by JBoss and Red Hat to work on these projects full-time, JVPM and rules, quite large projects, libraries, Java libraries that you can use or consume as services. I'm currently working in a different project that is also related to these topics, that it's called Activity. How many of you guys know Activity from the community, Java community in general? So Activity was designed as a process engine. I'm currently leading something that is called Activity Cloud, which is basically taking the best things that we have in that framework and just moving to a cloud, like a set of cloud-native building blocks that you can reuse when you're building distributed systems. Part of going through this journey was about that. It was going like away from Red Hat, moving away from this JBoss-centric view of the world of saying, okay, everything is Java EE based, to the different spectrum of using technology around the Spring community and Spring Cloud. So 9 months ago, we started working on this project. I took the lead, and we needed to make a lot of decisions around, okay, how do we use technology? What are we proposing? What kind of frameworks are we building for people to consume? And how this is going to look in the future. Because, of course, we started 9 months ago, so we need to plan for the future ahead, and we made some decisions around that. So for this project, the project itself, it's not relevant for this presentation, but I just want to give you a quick context about what we are building and the complexity of the things that we are building. In order to explain that, we basically defined like 2 big buckets of services that we are going to use and interact with. And this one, the first bucket, is a big one, which is called infrastructure, that contains most of the things that you will have in any cloud-native environment. Service registries, gateways, identity management, single sign-on, message brokers, timers, and all this kind of stuff. It doesn't mean that you need all of them, but if you are doing a cloud-native implementation, you might require some of them, so you should be able to pick and choose these services. And outside of that box, you have applications that are going to be able to interact with these services, right? So when we design of what we call application, we need to understand that there might be an infrastructure in there, and we will need to integrate with these services in a nice way. And we need to make sure that we have some abstraction layers for people to integrate different components in there, right? And then the second big bucket are applications. And I just want to explain that for us, applications are not just one service. It's not just one Spring Boot app. It's a set of applications that they need to interact together, and they are logically bounded, right? So they are providing a set of functionality, and they are composed by multiple other small applications, Spring Boot applications, and they need to interact, right? And then we will need to collaborate, make sure that we monitor these applications and understand when 5 of these services are up. That means that the real logical piece of application is up, just to make sure that you can understand the context. And we have most of our community users in the activity space. They are trying to build this kind of application. So that's why we want to provide these, these little blocks inside the application, so we enable them to build these things faster. In order to do that, we are doing something that not so many other open source projects are doing. We are just creating some set of blueprints of distributed architectures with some real concrete scenarios in mind, and we want to make sure that we publish this in a continuous deployment fashion, where we have these live examples up and running there, so you can go and see how they work, and at the same time you can see how they are configured, how they're working, and how they are integrating different components all together. I totally recommend you to check that out in our website. So going back to the topic of the presentation for a little bit, so what I'm seeing there in the Jakarta EE space, I do see that there is a new governance model, there is a new project, and there is a new group of people there called EE4J, which is calling the entire community to participate in the decisions about what's going to happen in that space in the future. I do see a lot of excitement, a lot of Java user groups joining that initiative in order to make sure that they do the right things. Now, having the project and the initiative outside of the company, it's a great thing. So I do believe that this will definitely speed things up. It will reduce the cadence of when we see more news about this. And then, of course, the microprofile project or the initiative as well, where you can see a lot of companies collaborating into making sure that we have a reduced set of of implementations for some bits of the specifications, in order to get the smallest possible thing there, focused on cloud-native applications, right? So I totally recommend you to check this out if you are coming from the Java EE world. This is kind of like where that community is going, and to be honest, I see a lot of excitement in there, and it's great because going through the standardization process always takes time. But if we can make that faster and leaner, we can all benefit from that. Even from the other side, from the Spring community as well, we can just benefit from that. So if you go to the microprofile side, you can definitely see the roadmap, and you can clearly see what are they planning to have there for version 2.0, that it's coming this year at some point. And you will probably, if you are like a Spring user, how many Spring Boot users are here in the room? Okay. Quite a lot. You will see some of the things that you can find in Spring Boot already, right? So the REST implementation or the specification for implementing a REST stack, and also JWT propagation, fault tolerance, open tracing, these kind of things. You will find in the Spring Boot. You will find it probably not by a specification, but they are using quite popular frameworks there as well. So I definitely love to see this, and I really enjoy looking at the news in there, in what's coming on. But at the same time, you go to the Spring Boot community and they already provide this kind of thing. and you can use it out of the box, and it's quite easy. So I'm just keeping an eye on both communities and trying to understand, okay, what's happening on the specification side, what can we use, what can we learn from there, and how can that be applied to the projects that we are creating. And if you are coming from the Java EE world and even from containers, you should definitely check out the Killian Project, which is basically an amazing project for testing general stuff, right? So you can test Java EE applications, you can test Spring Boot applications, you can test containers, and you can test also cloud deployments, which is kind of amazing. And for me, I knew and I used this for a long time. When I switched to the Spring Cloud stuff, they have testing tools. They have, there is a new project that it's called Test Containers that it's quite amazing, but I haven't seen that level of sophistication just yet. But you feel free to choose what works best for you. When you jump to the Spring ecosystem, and I will not spend that much time on this because you probably all know Spring Boot, I was looking. So when I did that jump, when I decided, okay, let's go full on Spring, because activity was very, very popular in the Spring community in general, we said, okay, let's take a look at what's there, what's available, and what are these guys doing, and how we can collaborate with them if we are going to release stuff on top of that, right? So as soon as you pick one of these libraries, you need to make sure that you understand that you are going to rely on that. So if something doesn't work in there, you have the duty of trying to report that and trying to fix that problem, and trying to interact with their communities to understand if what you are doing is right or not. So from day one, we picked Spring Boot 2, all the milestones. So 9 months ago, we picked like the very, very early snapshots, and we start building on top of that. And then we start looking definitely at the Spring Cloud, right? So if you want to build cloud-native applications, you definitely need to take a look at the Spring Cloud. So we did a quick evaluation, what's in a Spring Boot 2 GA already that it was published. Okay, there is a lot of cool stuff in there. You can probably find that out, and there were other sessions about this. But for us, this basically means, okay, what do we need in order to create a new service, right? And please, Spring Boot, take care of all the dependencies and making sure that all those things are working nicely together. So we can focus on the real business logic that it needs to go inside of our service, instead of caring about, how do we expose web services, or how do we, use hypermedia, for example. When we looked at Spring Cloud, it was quite clear to us that, again, going back to the previous session that was about, microservices patterns, is that if you want to implement microservices or, cloud-native applications, I do prefer the term cloud-native, which is much more concrete. You are going to look into having these components in your infrastructure, right? You are going to rely on these things. And if you really want to build scalable systems, you will need to have them, right? So you start looking at service registry, and I've heard like a lot of stories of Spring Cloud, people that it's adopting a Spring Cloud, that they say, okay, let's take a look at the the service registry, right? And they use Eureka for that, and they work with that, and it works nice. But then you start looking about, for example, Spring Cloud events, like streams, right? And that's another wonderful project. But it feels, when I start looking at it, I thought, okay, so these are nice projects. But then when you start using them, you start realizing that you will probably need them all if you want to build like large systems. And that's a more complicated discussion, right? Because if you need them all, then they all need to work together very, very well, and they need to be very, very integrated. So we look at this and we said, okay, we will rely on this. We will build our things and design our things based on the concepts that some of these things are going to be present. If they are not present, we are not going to use them, but if they are, we need to consume them, and we need to integrate our services against this. So we see this as glue and tooling for making all of our services to work together. We also see Spring Cloud as a great set of abstraction layers, right? Spring Cloud is basically a set of abstraction layers to say, you will probably have a gateway there. You will probably have a service registry. What's the implementation of that? Well, you can have different ones, right? So for service registry, you have Eureka, you have Consul, you can choose your own implementation. But again, that pushes you to make a choice, right? So when you start doing something, you can say, I will use the discovery client for the Spring registry, but then you need to go and choose one implementation there. So that's on you, right? And how do you make that decision? How do you choose between one or the other? It's kind of like taste. You can say, okay, I prefer Consul to Eureka, or there is something in one of these implementations that you like the most, or you have the most experience on, and then you use that to make that decision. So for us, this is the painful journey to the future, and I use this band, which is called Journey, by the way, and it's an American band from the 70s, that if you go to Wikipedia, they say that it's one of the most beloved band from that period, and also the most hated one. So it's a bittersweet journey. And in order to start that journey, it's very, very important for you to understand that I'm not saying just go full-on microservices or cloud native if you are starting from scratch, right? And this Martin Fowler slide, it's kind of like, I really like it because it has these two dragons like burning your weekends if you go straight to distributed architectures, right? We were in a very, very good position because we had a monolith, we have a huge tool with a lot of things in there, right? With a lot of services, with a lot of graphical UIs, and a complex setup that caused us like a lot of maintenance problems. So we knew where we were, and we knew which were our like core services that we wanted to do. So what we did at the beginning is we sit down with the team and we decided, okay, how many services do we have? 60, okay? Do we want to create new 60 projects from the scratch right now and integrate them all? No, let's choose the first 6 that are important, let's say 10%, that we know that our community members will, we will be able to start using right away. So we are focused during this last 9 months in building this core set of services that then we can start building on top of. So what we did at the beginning, the most basic stuff is, again, using DDD and using some common architectural patterns. We sit down and we said, okay, these are our 6 important services that we want to cover, and we define the scope of the services, the bounded context of each of these services, and then we start creating Spring Boot services around them. Again, what we did, it's of basic stuff. It's like one service, one repository. How many of you guys are doing something like that? Good. Some folks in the audience. It's kind of like a recommended practice. That's how we started, and it's kind of working nice for us now. Again, when you start going through this journey, the more that you can take from the community and from what other people is doing and from other lessons learned from other big teams, the better, right? So we started doing this. And as you can see, the only thing that you will find in here, it's a Maven project, some source code, and you will see the Docker file there as well, because we are going into that direction, right? The next thing that you will need to make a choice is how do you deal with dependencies, right? Like this shared kernel of things that all the services are going to use. And that's quite important. You cannot say, you can go and build any service using any library because nothing will work at that point. So you have different options in Maven, so you can use a parent relationship. All your services have a single parent, or you can use, the BOM, the bill of material side of things, where you just define all the managed dependencies that your projects are going to use, and then you import that into your project, so you just leave to this BOM to define which versions of which specific libraries. In our case, that BOM contains basically the Spring Boot version and the Spring Cloud version, right? It's all together. Then you go through this step of saying, okay, I have 6 services now. Okay, so you go and evaluate each service and said how these services depend on the infrastructure stuff, right? Like message brokers and database. And you start thinking about which ones are required, which ones are mandatory, and which ones are, kind of like optional, right? So if they are there, I will go to use it. If it's not there, I will just run, and I will just log saying, okay, this is not there, but I can just run. In this case, database most of the time is something that you need if you are going to persist some data. Message broker if you're going to emit events. Well, if it's not there, nobody will be able to consume what's produced, but I should be able to run and provide the service. And I shouldn't fail catastrophically if that's not there. So you need to start kind of defining what you need and what your requirements are. The next step, of course, it was Docker Compose in our journey. So imagine that you have a team, you are building stuff. The last thing that you want to do is you want to go to each developer machine and install a database and a message broker in there, because then the environment becomes a problem. So what you usually do, you use just Docker Compose to kickstart, database and a message broker, and then you just connect to them, right? So then you just replicate the development environment in every laptop of your team, right? How many guys you are using Docker Compose? Okay, good stuff. So next step is, okay, so now you have a Docker Compose with your infrastructure, then you have your services. But then you probably need to have, a Docker image built in from your service itself, because there might be some other teams that they want to have as their infrastructure or as their environment, your service running in there. So you basically try to wrap up your Spring Boot applications inside a Docker container. There are tons of ways of doing that. And again, you should rely on what other people is already doing and what other bigger teams are already doing and have experience on. We went through this journey of saying, okay, we can just do these multi-stage builds in Docker, right? So you can create 2 different things. So you don't include, so you basically inside this Docker build are using the source code to build the jars and then creating a Docker image on top of that. You do that in 2 different stages. So you don't add like Maven into your final Docker image. So you keep it as small as possible. So you can do that. And the good thing about that is that you can go through the next stage of saying, okay, if you have a Docker image somewhere, the last thing that you want to do is to build it locally and publish it, right? So you want something to build that for you, right? And you can definitely use Docker Hub in order to create these automated builds that it's going to pick up that Docker file and it's going to build the image and it's going to put it in the Docker registry so other people can consume. And again, we can do that because we are, a public project, like an open source project, so we can use all these features for free. But if you are in the private sector, of course, you will need to buy the private accounts or in GitHub and in Docker Hub as well. So that might be an option for you, or you might try to build your own Docker registry and keep your own Docker registry inside your company as well. We have seen that happening a lot. The other option is use some of the plugins if you want to build stuff locally and publish them to your private repository. We tried the Fabricate plugin, Docker Maven plugin, and it worked quite well. But it's quite a manual approach, right? So we are switching. We are not using any of these 2 things now. We are switching to another thing that I will mention later. And again, then you will see that you will need to create, again, environments for your consumers, right? So if you are building a UI on top of these services, then the UI team will need to have this environment set up somewhere. You will need to put it in a server, start it up, and maintain it there, and upgrade it as soon as you are making changes. So you will see here, again, in this slide, again, the 2 big buckets, right? So the infrastructure Docker Compose file, which will bootstrap the infrastructure, and then you can have templates for your applications. If you are building multiple applications, you can bootstrap these applications separately as soon as you build the Docker images for those applications. This is quite manual, and it's kind of tedious, and we struggled quite a bit on this during these last 9 months. So until there, the focus was, which services are we building, how do we integrate these services, and how these services are going to communicate, and what the infrastructure will look like in the future, right? So if we are going into this journey, we knew that there will be some common things happening in there, and we will need to make a decision between, from a service to another service, is it going to be a REST call, or is it going to go through the message broker? Are we emitting events in an event-driven fashion so some other service can consume that, or what are we doing? How is it going to look like? And then you start wondering about more complex topics about, okay, but if I have a gateway in front of my services, how do we expose web services that are, web sockets that are, being exposed from one of these services? And it gets much more complicated. So do we put the web services there in the gateway? How do we integrate? How do we do web services, WebSocket forwarding and all that stuff? And again, security, it's the other main thing, like single sign-on, right? So if you have multiple services, you want to make sure that every service, validate the JSON Web Token in there, and they do that in a secure way, right? So that's another decision that you will need to make. What do you use for single sign-on? What do you use for identity management? In our section of the industry, identity management is quite important. So how do you find users? How do you consume users that are created in LDAP or Active Directory? How do you integrate that, and how do you propagate that information to all the services? So it took us quite a while to make that definition. We think that we got something there that it's kind of like, okay, we are using a project that it's called Keycloak in order to do that, and for us it's working good for now. We don't know if that's the way into the future just yet. And then you start dealing with this kind of stuff. So just to go back here, if you take a look, so how many of you guys are using Spring Cloud? That's a good question. Okay, not so many of you, and for us it was kind of like not a revelation, right? But there is a point in time where you say, I'm using Spring Boot, great. Then you start looking at the Spring Cloud, and then you said, okay, I would like to use that one, that small piece, and then you start using it, and maybe it doesn't work for you, fine. But then when you look, the big picture is this picture where you see infrastructure and services and how they are going to interact together. And there is a point in time when you said, when it everything makes sense. And then when you start looking not only the gateway, but you look at the service registry as well, in conjunction, and how they interoperate, it really makes sense. So if you are thinking about cloud-native applications, that's the kind of picture. And Spring Cloud, it is kind of like, again, implementing the abstraction layers for building cloud-native applications, which for us, it's definitely where we were targeting. But we started in finding some of the things. So not everything is great in there, right? As usual, right? And as part of a community project, we want to make sure that we make this right for people using this. So for example, first thing, dependencies, right? And it gets quite complicated. Remember that we are building a framework for other people to consume so they can use different implementations. So if we create a service that it's going to use Eureka as a service registry, then you end up with dependencies in your services about Eureka specific, right? So if somebody wants to use console, then you also need to have in your service those dependencies, right? And then you can turn on and off these, different dependencies, but the footprint in your service is going to be higher. So the question is, where is the line? Where do you stop, saying I will support all these things, right? So this is something that you need to keep in consideration when you choose one of these things. It's a hard decision, then you need to say, okay, that means that my service is going to have a dependency on that component in some way or another, right? The same for tracing and monitoring, right? Like zipkin, you will end up having things in there in your services, and you will need to deal with that, right? Even though you will not need to deal with the version because Spring Cloud is supposed to be providing that for you. Well, you need to make sure that that's correctly integrated and it's working for your scenarios. So you need to go through that journey anyway. So until there, definitely you can find this book. I don't know how many of you guys have looked at this book. A couple of guys. Totally recommended. If you are a Spring Boot user, totally recommended to go there because this where is you can see the whole picture, right? The whole picture about why Spring Cloud, how everything is designed together, and it's kind of coherent. Which are the implementations that are suggested, and which patterns from cloud-native applications are they implementing with these components. At the end of the book and towards the end, you can clearly see that the Spring Cloud and these frameworks were designed with the idea of Cloud Foundry in mind and extended for to provide different implementations so you can use it outside, but you can clearly see the influence in there. They also, at the end, cover concourse and how do you build continuous deployment pipelines for these infrastructures, which is quite important. But there is always a big but, right? But Kubernetes, right? So that's not even covering the book, and that's perfectly fine. And I could expect a new book coming covering Kubernetes, right? And I do believe that it's right not to be covered in that book because Spring Cloud was not designed for this. It wasn't designed for this with this in mind because this is quite new. And we are definitely targeting in our project this platform for our main deployment platform. And when we started 9 months ago, it was a vet in general. Like we were saying, okay, we need to make a choice. What's going to be our platform? Are we going to rely on Cloud Foundry? Are we going to go to Heroku or some other cloud provider? Are we going to go to Amazon? Well, we need to make that decision, and we make the decision to go through Kubernetes because we believe that Kubernetes is a great, again, abstraction layer for cloud providers. And at that point, we didn't know, but we had a very good hunch on what's going on in the industry. And how many of you guys are looking into Kubernetes at least? Just looking, right? Because it is true, it's quite early, and there needs to be a lot of things happening in that community for these tools become, easy to use and easy to manage and easy to integrate with your applications. So we are going through that journey. They are going through that journey as well. And what we see is that there are a lot of tools, there are a lot of simplifications, there are a lot of things happening in that community that it's going to make our life, like as a Java developers, simple. So Kubernetes, for the ones that doesn't know, it's like a production-grade container orchestration. When do you need that kind of stuff, right? When do you need that? You need that when you have tons of services. If you have 40 services and you want to manage them, Docker Compose for us, it's kind of like a toy, right? You can start your containers and you can restart them if you want, but you need an orchestrator if you want to handle a large set of services. And we did like a survey in the community where we just went out and find what people is doing with our projects, and they are usually big organizations that they want to build, large applications. So for them, this makes a lot of sense, right? Of course, you can see here, like the website, the first thing that they say, it's planet scale. So do you need planet scale? Well, maybe not. I mean, it really depends on what kind of software are you implementing. So you need to be wise, and you need to understand that, this is where cloud providers are going. This is where you probably are going to run your software in the future, and unfortunately, at this point, you kind of need to know. It's not that you will code your application and it will automatically run in there. You need to follow some patterns, right? They have created the Cloud Native Foundation, another great initiative in there, just to make sure that whatever it's done in these communities, it's following some patterns. So as soon as you follow these patterns, I mean, you should be fine. But you need to know that you are targeting that kind of stuff. You cannot target this and some other things as well. Again, when we started, we didn't knew that the picture was not like this, but we knew that Google, the ones that open source Kubernetes were using Kubernetes there. We knew that Red Hat had OpenShift based on Kubernetes, like for the last 3 years, so they have experience in there. But we didn't know that Azure and AWS and Docker will provide support for Kubernetes, and Pivotal, Cloud Foundry, the ones that created Cloud Foundry, are going to support Kubernetes in there, and they are building the new version of Cloud Foundry on top of that. We didn't know that, but we knew that we can use Kubernetes as an abstraction layer for deploying our stuff. And we know that as soon as we run in Kubernetes, running on these different flavors of supported Kubernetes, it's going to be way easier than it is right now. And we should be able to consume more services from them later on if we run okay in Kubernetes. So basically what I'm saying is that we are having this in mind, and I think that that's kind of like important nowadays. So what did we do in our project? We went there and we started playing with it, and we said, okay, in the same way that we had the Docker Compose files that describe what needs to be started with Docker images do we need to start, we started creating deployment descriptors for Kubernetes. And again, you will see there the application template and the infrastructure template, which says, okay, just deploy all the infrastructure bits and then start deploying applications on top of that. Creating the descriptors is a very tedious task, right? So you need to know what you are doing. You need to definitely understand how Kubernetes works. You need to understand what's a pod, what's a service, what's a replica set, and all these things. And to be honest, that's what scares me the most, right? So if I want to teach a graduate student coming out from the university about all these things and how they work and why we are going there, it gets quite complicated. So as a Java developer, I totally recommend you guys to take a look at how this technology works, mostly because you probably will end up running your software in there at some point, in some shape or form. And then, of course, during our journey, we thought, okay, so because again, I was coming from the Java EE background, I didn't know what's the relationship between Spring Cloud and Kubernetes, and there are a lot of, Spring Cloud, they got their abstraction rights from the cloud native part, right? But they haven't played that much with Kubernetes. They are now playing with it, and what's happening in the community is that those abstraction layers needs to change a little bit in order to support, that kind of infrastructure, that kind of platform. And as part of an open source project, we are trying to make sure that we collaborate in order to make them know how are we using Spring Cloud in these environments. And if you are looking into this, I totally recommend you to just follow that approach. Get in touch with the guys. They are very open, and collaborating with them is always, an interesting experience. You learn a lot from that. So when you go to Kubernetes, the picture changes a little bit, right? The picture changes a little bit because there are some of the things that are going to go away, like service registry and config server. The last thing that you want to do when you go to Kubernetes is to start putting into Kubernetes tons of containers that you don't really need, because Kubernetes already provides a service registry that it's built in Kubernetes, so you can use that directly instead of putting Eureka in there. The same for config server. You have config maps in there. They support configuration and the consumption of that configuration from your services in a native way. It's there, so you don't need another extra container in order to get that features in there. So the question is, okay, so how do you work? What do you do? How do you know that you need a service registry, but now you cannot use Eureka, or it feels completely wrong to use Eureka in this place. And also when you start going to more looking not only in Kubernetes, your installation of Kubernetes, but something that, for example, Azure or AWS is going to provide, you start thinking about all the infrastructure related things like databases and message brokers and all this stuff. It should be provided by us. I mean, as developers, the only thing that we should say is that my service depends on a database. These are the credentials. This is the schema that we need in there. Please provision one for me. And the cloud platform should do that for you, right? So how do you do all these service bindings? How do you deploy stuff in there and make sure that they can figure out what's happening and just bind to these services? And that's a very interesting question, because if you go to Kubernetes, that's not in the base Kubernetes a set of capabilities. So what do we need in there in order to get those kind of things? And the next step, of course, is pipelines and accept and test, right? So you need to get ready to create pipelines. And in order to make this work, because you have a lot of services going on, you have a lot of infrastructure-related things, so you need to make sure that you have pipelines, that you deploy stuff to different environments, and then you just test, you do integration test all over the place. So you need to be good at this, and to be honest, I wasn't particularly good at this, so I'm kind of like learning a lot about how to do this. And one of our objectives in the open source project is to make sure that, again, we have this continuous deployment methodology. So we go through the pain that people that is going to consume our services is going to go through that. And that's why during these last weeks, I've been playing with Jenkins X. How many of you guys knows about these projects? So how many of you knows about Jenkins in general, right? So we all know about Jenkins, the good old Jenkins, right? Jenkins X, completely recommended if you're looking into Kubernetes, right? Again, this is all about looking at other people and how they are doing stuff in these environments. You cannot have all the answers. You can go there and invent all the answers. You can make your own answers. But looking at what other people is doing is definitely the way to go for these complex topics, right? So I've been looking at this, and basically what they provide is an integration of Jenkins inside Kubernetes, and the generation of the pipelines for building your microservices and deploying those microservices in different environments, right? Like staging, production, and doing the promotion between the environments. So we are definitely moving in that direction. So you will see that our repositories and our examples, they all contain some kind of description of how to build these projects in there, mostly auto-generated by this project. So when I look into the future, or when I look into my to-do list for the next 6 months, I would say, we are looking into these topics, and I would like to invite you, if you are looking into Kubernetes and all this stuff, to take a look at these projects as well. So Spring Cloud Kubernetes is the one that I got most involved with, because I do believe that that's the project. It's an incubator project that it's there, basically providing some implementations for running your services in Kubernetes. That idea of relying on the service registry that is provided by Kubernetes, and how do you use, you don't change your application that it's using Eureka to run in Kubernetes with their own service registry. So there is integration there for the service registry, for config maps, for Ribbon, for doing client-side load balancing as well, that you might need or you might don't need, but it's a good integration that it's there already. And in that project, what we are looking into is taking a look at all the other things about Kubernetes Service Catalog, and this is going back to the idea of binding services, right? So if you deploy a database, or if you need to provision a new database container for your application to work against, you should be able to do that with like a binding or like a service broker approach, right? That's a very well-recognized pattern that it's, if you go to Cloud Foundry, they are doing that. That's why they open source this Spring Cloud Open Service Broker project that allows you to do that kind of service bindings with that. You, of course, need to deal with secrets, and you need to deal with infrastructure as a code, right? So you have your environments defined in a GitHub repository, and then you can reproduce that very, very fast. Security is always a thing, so we are looking at Kubernetes X, which is it's a project that it's growing and growing and growing, and this is, again, how do you do single sign-on? How do you do identity management integration in these environments? How do you do role-based access control in there? How do you propagate that information? We are definitely looking at Istio, again, going back to the dependencies and the responsibilities that you're going to put inside of your service. That's quite important, and those are the discussions that are happening there in the Spring Cloud community. What are the things that are supposed to be inside your services? What are the things that are supposed to be delegated to the platform? Where is that line? What are the things that we're going to recommend, and what's the opinionated view from the Spring Cloud community to those topics? And Istio comes in there because it provides a service mesh, it provides security and the things that you usually don't want to deal with, right? They wrap your service, they provide monitoring and look into that in a unified way. So you just stop dealing with those things that are cross-functional inside your service. Just delegate that to the platform. And then we are looking at communities like JHipster, because of course our community users and our customers are going to build UIs. And if you look at JHipster and how they created this project for integrating a Spring Cloud with Angular as a front end, it's quite interesting because it's quite similar to what we are doing. We see tons of different projects going through the same journey of saying, okay, yeah, you will have environments, you will have UIs, you will have backends, you will have tons of services, you will need a gateway. If the UI needs to contact a service, it will go through the service registry. So we are closely looking at this and making sure that whatever service we create, it will work in that approach, right? And we can use all the scaffolding tools for generating UIs for our services. So I totally recommend to take a look at this. Again, this is the incubator project that is going to go out of the incubator, I would say, in the next months. I totally encourage you to take a look and to start playing around with. And I will start publishing some examples that I'm doing on my own, so to test that this stuff is working correctly. Finally, I have 10 more minutes. Before the thanks, I wanted to show you quickly what I've been playing with as an example of what the Spring Cloud Kubernetes is doing in general. Let me exit this. And again, a little bit about Jenkins X, which is, not that one. Where is it? Here. Yeah, so that's the project. I totally recommend you to take a look at that. And again, what is it? I mean, is it just installing Jenkins inside Kubernetes? No, it's definitely a lot more than that. It is a CLI tool. It's Jenkins in there, but it's also all the glue that you need in order to get your project from source to something that is deployed inside Kubernetes. And that's kind of like a lot of things. There are a lot of things that needs to happen, and you shouldn't invent how to do that. You shouldn't try to create your own standards on how to create the scripts. You just rely on some other communities that are doing a great job around that. So what I'm going to show here is I have a service running inside Kubernetes, and again, this might go wrong because it's remote, it's running in AWS. I created an AWS cluster with Jenkins X that allows you to do that and install Jenkins X in there. So Jenkins X has this command that allows you to see and interact with different environments. So you can do something like jx status to see if it's running or not. And again, what I have, well, it will take some time depending on the Wi-Fi. Yeah, so it's running. And then you can do something like jx log, right? So I have one single service that is running there. It's a service that it's called Minion, which is basically a worker, something that it's going to do something. But minions, in general, they need a boss. They need to do something, but they need to ask someone to do that. So basically what this service is doing is using the discovery client provided by Spring Cloud again in order to use discovery. So you can just check which other services are around. And basically what this is doing is looping through that list of services every 5 seconds and saying, do I have a service with some metadata? It's like a boss service there. So basically it's checking by that. And if there is, it's sending a request. So it's saying something like, I want to do something. Please tell me what to do, right? But again, this is happening dynamically. When I deploy the service, there is no boss service in there. So basically what we are getting in the output is saying, okay, there is no boss found in there, right? And this will keep running until it finds the boss. And as soon as it finds the boss, the minion will be happy. Right, so what you can do with Jenkins X is you can import your applications. This is just a Spring Boot application that I've imported there, and they will generate all the pipeline, and they will generate, a Docker image for that. They will build that, everything almost automatically for you. So I wanted to show you that. So that's my Minion, right? That's my service, and that service was exposed inside the Kubernetes cluster. For me, it's sad because it doesn't have any boss to talk to, right? And the main idea of Minions is that you can create more. I can start creating replicas of this, and I will have an army of Minions. I will not demonstrate that now, but I just wanted to demonstrate a little bit more about this. So I have these things. I knew that will fail. So what I have here is like 2 things. I have 2 environments, one called staging and another production. They are both attached and associated to pipelines, right? So they are GitHub repositories there that you can treat these environments as source code, so you can send pull requests and change the environments and change the requirements. And I have this service already added there. What I will do now is I have the other project that it's, again, a most simple Spring Boot application that it's called the boss, and it just has a controller where it just prints out the boss, and it also accepts missions, right? Mission requests, right? Again, extremely simple example, and I hate to build these extremely simple examples, but I wanted to demonstrate a point and to make it easy. So what do you do in Jenkins X? So first of all, you have environments. So you can just switch to the dev environment. It will take some time. It's going to AWS and check what's the environment, and it's switching there. Now I'm there, so you can do, for example, get apps in order to see what's in the dev environment. And what's in the dev environment, it's all the tooling from Jenkins. So we can see, sorry, no, that's not, I can do this. Get pods, just to see what's running in there, right? And what we are going to see is that all the containers and all the things that are integrated together, right? So you will see that there is Jenkins, of course, running. We have Chart Museum for hosting our Helm charts, which are the way of doing deployments in Kubernetes. It's like a standard way nowadays. Again, as I mentioned before, if you're building Docker images, you will need a Docker registry. Can make it bigger. And you are going to need, for example, Monocular as well to browse your Helm charts. And if you are building Maven projects, you will probably need Nexus in there. You need a place where you want to store your artifacts. If you want to share those artifacts and you want to cache them, so you don't download them every time that you need to build something. And then you will have some Maven pods that they're going to build your projects, and they will be created on demand based on the requirements. So the next thing that I can do is I can import my project in there. Right? And I need to make a change because my configuration is a little bit messy. But basically what I'm saying is I'm importing this project to Jenkins X, meaning that I'm going to a GitHub repository with this project is hosted. I have this project in GitHub, so this is basically going to use my user to create some webhooks into that repository to listen to changes. And it will automatically generate, as I mentioned, it will generate the pipeline description about how to build this and move this through different stages. It will generate some charts in order to say, okay, this is how the deployment will look like, but it also supports preview for pull requests. So you can send a pull request. It will create an environment for you where it will deploy that stuff so you can test before merging the pull request with your changes. And it will also create, some descriptors that I mentioned that we created manually before, and that's not the way to go. So we are now relying on these auto-generated ones and touching them as soon as we need to make some changes. So now I have my project in there. The main problem is that I need to make a couple of changes here in the pipeline because I'm using, a different branch from the default one. So I will do this quite fast. Develop. So just changing the branch that it's. Where is it? Okay, so somewhere there. I'd say done. So git add. Git commit. I just want to show the other thing that I'm really, really amazed about this project is that you don't really build anything anymore in your laptop. You don't need to build Docker images or download Maven artifacts. The pipelines will do it for you. So if you are in a very unreliable connection, this will work. So, right. So I will just push this, and as soon as I push this, push. Sorry if it's down there. As soon as I push this, what I will be able to see here is that now I have a new project and I have a new pipeline and I have 3 minutes left, and I think that the pipeline take around 2 minutes. So I will try to explain what's going to happen now. So basically this is picking up the new work, the new job in Jenkins. I haven't created that job, or I haven't created anything. I just imported the project. Everything was generated for me. And of course that we can switch to the new UI, which is a little bit better. So now Jenkins X is waiting for a job executor available so it can build that project. But what's going to happen is that it's going to go to GitHub. It's going to pick the source code from that project. It's going to clone it. It's going to build it using Maven. It's going to deploy that Maven into the Nexus internal repository that has inside Jenkins X, and it's running inside Kubernetes. It's going to reuse any other downloaded artifact that it has already there, so it will be quite fast. It will not download everything for every build. And then it's going to create the Docker image for that. It's going to publish that to the Docker registry. It's going to create the Helm charts and publish that to the Chart Museum repository so other people can use these charts to deploy our service. And it's going to promote that service into the staging environment, the live environment that we can use for testing what's going on with our services. So at some point when this pipeline is finished, you should be able to see the service up and running, and the other service kind of like finding the new service that was deployed in there. So they are doing a lot of magic. They are relying on standard tools and standard practices that they are gathering from their own communities. Jenkins, they have a lot of experience on how to do this in an automated way, so they are trying to make it as simple as possible for you to going from source that you have in GitHub or in any other Git repository to something that is live and running in your Kubernetes cluster. So I'm quite excited about this, mostly because it means that what we are doing, and as soon as you know about the pieces and how they work, using these tools is extremely simple. And dealing with different environments, it's it's being provided by these tools already. So you don't really need to do much. You just need to understand how it works. And instead of spending a year trying to figure out how to do all those things in your environment, you just can rely on these tools. And if you don't want to rely on those tools, at least you know how those tools are doing things, so you can just copy and take the best practices from them. Again, as I mentioned before, because this is handling environments as Git repositories, they are basically, in order to promote something from one environment to another, they are sending a pull request to a different repository, checking those pull requests and building those to validate that everything is fine, and then the promotion will happen automatically here. So yeah, at some point I have 30 seconds left, and sorry about that, but you can do something like env staging. I'm switching now to a different environment, which in Kubernetes means a different namespace. And now I'm in that environment. Clear. Let me see. So you can do something like see what's running, get pods. Yep. Anyway, at some point you will see here we have one pod up and running, one container it's up and running, and then at some point when the pipeline finished, a new container will be started, and it takes some time. It's the first time that I imported that project, so it will take some time in downloading and merging stuff. You can clearly see that it's waiting for that pull request being merged by another pipeline that it's running. Totally recommended to check it out if you're into Kubernetes and if you're building cloud-native applications. It makes your life completely easy in general. And again, take it between quotes. It's kind of new. We are an open source project. We are picking up into these new technologies because we believe that that's the way to go. Our roadmap might be completely different to yours, so take that into account. These are very, very cool tools to play with, but then you have your life and you need to implement stuff for tomorrow. We are thinking a little bit more outside the box and the long term instead of tomorrow. So that's pretty much it. Thank you very much. We are quite open in general, so please feel free to get in touch. To join our GitHub channel, and again, our blueprint is just a cloud-native application that you can pick up and rely or copy some best practices from there. Thank you very much.